Hey, thanks for tuning in. We're going to do a very fast recap of today's notes on operating with complex numbers. It sounds so crazy, but what you'll see by the end of the video is literally relying on a lot of skills that you learned as a freshman or maybe even a 7th grader with one added thing. We're basically going to be combining like terms or multiplying things together. And if we happen to see an I squared, that's going to become a -1. One of the challenges of this new topic is understanding when you're supposed to add or subtract or multiply, because you're going to see a lot more parentheses than we normally see. Like, for example, on the page right here, examples A and B, there's a lot of parentheses there, but A is an addition problem and B is a subtraction problem. C is a multiplication problem. Look how similar A and C look, though. So what often happens when kids are doing this stuff for the first time, like you guys are, is they want to treat this problem and this problem almost exactly the same, whereas like they want to multiply everything together because of the parentheses, but that's not how I'm going to handle answer A. If I see a plus sign between the parentheses, that's an addition problem. And for addition problems, all we have to do is combine like terms. So it's kind of like two things. You have to know to ignore the parentheses there and just combine like terms. If I was doing the very first problem, the one complex number is 4 plus 2i. The other complex number is 5 minus 8i. I'm going to add them together by just dropping those parentheses. They're not really doing me any favors. They can just go away. No reason why I can't just get rid of those. And then these are like terms, so I'll combine them. And then these are like terms, so I'll combine them. And these are not like terms, so that's my final answer, 9 minus 6i. Question B is very similar in that right between the parentheses there's a big subtraction sign, so I'm going to ignore my default of seeing parentheses and assuming that I'm multiplying. I'm going to fight against that. But I will say what's getting subtracted in part B. What's getting subtracted is this entire complex number. So I had to do a little more work to get rid of that parenthesis. If I want to subtract this entire complex number, I've got to basically add the opposite of this complex number. This is kind of like when you first learned about addition and subtraction with integers as a kid, and your teacher was like, hey, if you have 5 minus -3, change that to adding the opposite. It's a similar idea. We're going to add the opposite, and that's going to look like this. Get all the extra marks out of here. When I see a problem like this, I'm like, uh-oh, there's a big fat minus sign between them. I'm subtracting. Let me take this negative sign and distribute that to each part of this. Make it a -5 and a positive 4i. Whoops, my 4 looks like a 9. And then this is going to also be just what it was. Now my parentheses are removed correctly. And I'm just going to go ahead and combine the like terms. So 6 and -5 are alike. They make 1. 10i and positive 4i are alike. They make positive 14i. And it's all copacetic. C and D, same ideas. We're going to multiply some stuff together, though. There's no symbol between those parentheses, so it is straight up multiplication. This is when you were a freshman, you might have learned this as foiling. What I prefer you to think about this is kind of like a glorified distributive property. I'm going to take this, everything in this set of parentheses has to multiply by everything in this set at some point. So the organized approach is to look at the first thing in this parenthesis and multiply it by everything in the second set. 3 times 1 is 3. 3 times -5i is -15i. And I'll say too, like I said during class, if me saying I is making your shoulders tense up, I don't know what that is, Mr. Dubsick. This is making me nervous. What I want you to remember is if you need to replace these with x's while you're working with the problem, feel free to go ahead and do that. If you're more comfortable taking 3 plus 7x and multiplying by 1 minus 5x, knock yourself out. It's just a different letter, so it really shouldn't bother you. But I might have had to do a few like that before when I was a youngster. All right, so 3 times 1 is 3. 3 times -5i is -15i. Moving on to the next number in the parentheses, 7i times 1 and 7i times -5i. So 7i times 1 is just a 7i. And 7i times -5i is -35i squared. Okay, not too shabby. Now I need to go through and look at where my like terms are. If these guys are alike, they're both just a single I, and they combine, they're enemies because one's negative and one's positive. They make negative 8i. So I'll have this 3 in my answer. I'll have a negative 8i. And then the other piece that's weird that makes this different is I squared equals negative 1. So that means if I have a negative 35 times I squared, it's like I have a negative 35 times a negative 1, which is positive 35. So this whole thing, because of the I squared, instead of negative 35 something, it becomes change the sign and keep the number. Negative 35 I squared becomes positive 35. Now I'll admit that is a little bit strange. If that's bothering you, I'll make another video for example C, try to clarify it. But if you understand, like you just want the recap of today's notes, that's what happened. And now I do have like terms again. 3 and 35 make 38, just combining like terms. And then 8i is not like them, so it's by itself. That's my answer there. This last example on page 13 is, well, I got a number on the outside. I got some parentheses going on here. I'm going to think about this the exact same way I would think about something like this. So if I'm doing this and I understand that 4x times negative 6 is negative 24x, and 4x times x is 4x squared, this is the same process. Nothing to sweat about. It's just i's instead of x's, at least in the beginning. So 4i times negative 6 is negative 24i. 4i times I is positive 4i squared. But then it's like, oh, I squared, I can't leave that way. That's not okay. I squared is negative 1, so positive 4i squared becomes negative 4. So I get negative 24i and a minus 4. Now, technically, you're supposed to write the real part of your answer first. So negative 4 minus 24i is my final answer on that. So I hope what you see is essentially we are either combining like terms, right? Putting i's together, putting things that are not I together. Sometimes we have to distribute a minus sign before we do that. That's what A and B were all about. And C and D were our old tricks about foiling binomials or multiplying a number inside of parentheses, with the added step of, if you see an I squared, that I squared goes away and the sign of the number in front of I switches. So like the negative 35 I squared became just a plain old positive 35. The positive 4i squared became a negative 4. That's it. Don't overthink this. Just do your best with it. It's going to be fun. And I have another video for the second page if you missed those as well.